When you're creating objects and classes in Python, you're going to want to give them some functionality, and that functionality is usually created with methods. So let's go ahead and make a working copy of classes.py, and we'll call this classes-working.py. We'll open up that working copy. You see that we have a class called duck, and it already has a couple of methods in it, quack and walk, and those get called down here. So Donald gets created as class duck. So this is an object with that class and the object Donald. And we're calling the quack method on the object Donald, and we're calling the walk method on the object Donald. And the calls are done using this dot operator, which is used to reference an attribute of the object. In this case, the attribute is a method, and so it's called with the parentheses. And that calls it as you would call a function. And these are actually functions. It's just that these are functions that are attributes of an object. And that's what makes them methods. So we'll go ahead and we'll run this, and you'll see that the object gets created and the methods get called, and it prints out quack and it prints out walks like a duck, and everything is working like we expect it to. So the methods are actually functions, and you'll see that they're defined just like you define functions in Python. The difference is these are indented under the class duck. And so that makes them methods of the class duck. You'll also notice that the first argument to these functions is this word self. And that is a reference to the object, not the class, but the object. In other words, when quack gets called on the Donald object, then the Donald object gets passed to the quack method, so that quack has a way of referring to object attributes. You'll also notice that nothing is getting passed inside of these parentheses. It's as if Donald was passed inside those parentheses, but you don't actually put that there. That happens automatically by virtue of the dot operator. When quack gets called as a method of Donald, then Donald gets passed magically inside those parentheses so that it's the first argument to the method. There's a special type of a method that I want to talk about, which is called a constructor. And this gets called every time you create an object based on this class. The constructor in Python is created by naming a method with 2 underscores and the word init and 2 more underscores at the end. And this creates a constructor method. So I'm just going to print constructor here, and we'll go ahead and we'll save this and we'll run it. And you'll see that constructor gets printed at the beginning. And so when we run this, the first thing we do is we create the Donald object, and that's where the constructor gets called. In fact, one of the most common purposes for a constructor is to initialize some data. So if I put in a number 47 here, and then I pass in that value in the constructor, I'll say value here. Instead of printing constructor here, I can save this value saying self._v equals value. And what this does is this creates a local variable that is an attribute of the object, in this case the Donald object. But if I had different objects with different names, it would be attributes of those objects. And we'll see how valuable this is in a moment. Then I can use that value in the methods. For example, I can print it out here. And I can print it out here. And so now I'm initializing this variable to the number 47, and each time I use it, I'm going to go ahead and print it out. So we'll save this and run it. And now we see that we have a 47 here and a 47 there. If I were to change this to something else, save it and run it, then we have 52 here and 52 there. If I create a different object with a different number in it, and go ahead and call it. Now when I save that and run it, then we have the Donald ducks and we have the Frank ducks. So the value here is that this self_v is actually attached to the object, not to the class. This is what's called encapsulation in object-oriented programming, because that value is a part of the object. And so I can have different objects with different values. and I could actually have all kinds of different data associated with those objects. They could be opening different databases, they could be accessing different files, they can be keeping their place in these databases and in these files. And this is the power of encapsulation in object-oriented programming. And we'll see a lot of examples of that as we move forward. But for now, what's important to know is that all this happens through this self variable, right there and right there. When the object calls a method, that self variable gets passed, and that's a reference to the object, and all the things that are attached to the object, its other methods, its attributes, its data, is all carried there. So here we've defined methods in our object, and these methods are defined in exactly the same way that we would define a function in Python, except that its first argument is always self, and that argument doesn't get passed explicitly, it's passed implicitly through the dot operator. And we have a special method called init, which is used as a constructor. We can use that to set up data, we can use it to open databases, we can use it for all kinds of purposes. The point of it is to initialize whatever needs to get initialized when you create the object based on this class. And so that's how you can create a constructor, and that's how you create methods in classes that will be used in objects in Python.